Hello dear students, I welcome you all in University Chemistry class. Students, in manufacture of basic chemicals, so far we have discussed manufacture of two chemicals. In previous lecture we have discussed manufacture of ammonia by modified Bosch-Couple process. The process starts from the starting material, there is a producer gas and water gas. Further we compress and then we react, maintain the ratio, then we react further using finely divided ion catalyst. Further cool down the reaction mixture, ammonia gas, we separate out the unreacted gas and the ammonia gas. This process we have discussed in last lecture. In today's lecture, we are going to discuss about the manufacture of nitric acid by Ostwald process. That is nothing but ammonia oxidation method. Students, keep in mind, if you see the structure of nitric acid, I always keep telling you, you see the number of nitric acid, you see the molecular formula, hydrogen is involved here, hydrogen is there and oxygen is there. So one can simply imagine or think that this many starting material is needed for the manufacture of nitric acid by this method. So how to bring this hydrogen, how to bring this nitrogen, how to bring this oxygen? Keep in mind, this comes from the oxidation of ammonia. It is also called as ammonia oxidation method. And hydrogen comes from the water. If you see the chemical reactions involved in the manufacture of nitric acid by Ostwald method, the first method is oxidation of ammonia to nitric oxide. This is the important step in manufacture of nitric acid. Oxidation of ammonia with the help of oxygen in presence of platinum-Rhodium catalyst at temperature 750 degrees Celsius, it gives nitric oxide as well as water. Further, next step is oxidation of nitric oxide. The nitric oxide, which is obtained in the first step by oxidation of ammonia, is further oxidized with the air and it gives this nitrogen dioxide. And the last step, absorption of nitrogen dioxide by water, it gives this nitric oxide and some amount of the nitric oxide, which we can recycle to get this nitrogen dioxide. So from this you can easily see that the starting materials needed for the manufacture of nitric acid. The first starting material is ammonia. The second starting material is pure air or oxygen. Third starting material is catalyst, that is a platinum and rhodium gas catalyst, and water. Already we have considered this oxygen here. So four starting material is needed for the manufacture of nitric acid, that is ammonia, oxygen, platinum-rhodium catalyst and the water. So keep in mind, this is important for your university exam. If MCQ type question will be there. Starting material for the manufacture of nitric acid is ammonia, oxygen, that is pure air, catalyst platinum-rhodium catalyst, and water. The first step involves oxidation of ammonia with the air using platinum-rhodium catalyst, which gives nitric oxide. Nitric oxide on further oxidation with the air, which gives nitrogen dioxide. Further absorption of nitrogen dioxide with water, it gives HNO3. In addition to this, nitrogen dioxide can be absorbed in presence of air also, and it can give nitric oxide. But simply you keep this thing in mind, these three steps: oxidation of ammonia, nitric oxide, oxidation of ammonia to nitric oxide, oxidation of nitric oxide to nitrogen dioxide, and further the last step is absorption of nitrogen dioxide with water, it gives nitric oxide. So if you got this reaction, so simply you put this reaction in flow sheet diagram. Imagine that how this reaction we can put it in flow sheet. So now you got the first point which I have discussed, that hydrogen comes from the water, this nitrogen comes from the ammonia, this oxygen comes from the pure air which is used for the oxidation. So even by seeing the molecular formula of nitric acid also, you can easily predict, or you can easily think that what could be the starting material for the manufacture of nitric acid. So as we are doing the first step, oxidation of ammonia to nitric oxide, so of course then we need these two starting material. So first, anhydrous ammonia, which is obtained by modified Bosch-Haber process, and the pure air. Keep in mind, if air is not pure, then further purification process will get lengthy or impurity will get generated in the process. So imagine here the pure, that is anhydrous ammonia, and pure air is needed. Ammonia first is passed into evaporator, is the steam evaporator, and air is passed. Air is then first compressed to 6.8 atmospheric pressure. It is converted into liquid, then it is filtered, and this anhydrous ammonia evaporated, steam evaporated, is passed into reactor. So now this first step takes place here. Anhydrous ammonia is passed here from the evaporator, and the pure air is passed, first compressed at 6.8 atmospheric pressure, filtered, if any impurities is there, it's filtered and it is passed into reactor. In reactor, the first step will take place, the formation of nitric oxide. Reaction is exothermic, so these reaction gases are cooled, and further where nitric oxide, formation of nitric oxide will take place, and the next step will also take place in reactor, where nitric oxide to nitrogen dioxide, these reaction gases are cooled and it then passed into one tower. There is a stainless steel tower, from where water is poured from the top of this stainless steel tower, where this absorption will take place, and it will give this nitric oxide, and the yield of the nitric oxide is obtained is a 65% by this process. And the waste gases which I have shown here, upon absorption of this nitrogen dioxide, which gives nitric acid, but some amount of or unreacted waste gases comes out from this reactor. So students, flow sheet is very simple compared to contact process and sulfuric acid manufacture of sulfuric acid and manufacture of ammonia. Ammonia and air is passed. Ammonia is evaporated in steam evaporator. Air is compressed, filtered and mixed into reactor. Where it is reacted, ammonia is get oxidized by using platinum-rhodium catalyst to nitric oxide. Further, nitric oxide is converted to nitrogen dioxide by maintaining the volume 1:10 of ammonia and air. Here, volume is maintained 1:10 ammonia and air. On oxidation of nitric oxide to nitrogen dioxide, the reacting gases are cooled and then it is passed into the next stainless steel towel, from where water is poured from the top of the towel. On absorption, nitrogen dioxide gives nitric oxide, and unreacted nitric oxide and waste gases comes out from the top of the towel, which gets recycled again in the reaction, where we can get the nitrogen dioxide, and further absorption. This recycling process will take place and we will get the nitric acid. So students, this process is very simple. Keep in mind, first oxidation of ammonia to nitric oxide, then oxidation of nitric oxide to nitrogen dioxide, then absorption of nitrogen dioxide by using water to gives nitric acid, and it gives waste gases also. So simply by remembering these three steps, you can write this flow sheet. Students, I hope you got the manufacture of nitric acid by Ostwald process, that is nothing but ammonia oxidation method. Thank you. Thank you very much. Thank you. Thank you very much.